Hello, this video is another video on color subtraction, but instead of talking about filters now we're going to be talking about colored objects. It's still subtraction, but in a different way. And then at the end of this video, we'll add colored objects with colored filters and it'll be all exciting. So let's get going. A reminder, red, green, blue are our primary colors. Yellow, cyan, magenta are the secondary colors of light. We're going to talk red, green, blue for everything because that's what white light is made up of. Now to start talking about colored objects, we need to make sure we understand how we see objects to start with. So if you see this green rag, how are you seeing it? Well, okay, in order to see something, there must be a source of light right there, okay? There's a source of light. I have my object, source of light, object, and then the third piece in order for you to see it, your eye. So if we have a shirt, let's say, then we have a source of light, sunlight or whatever, and then your eye, the way that light travels is light starts at the light source, it illuminates the object, and then light from that object must go into your eye so you can see it. So that's the basics of just how we see things. Now, what if we make this a blue shirt? Okay, so blue shirt. We've got white light illuminating the blue shirt, which means we've got red, green, blue coming in. Got three colors of light coming in. But when we see it, we only see blue. So we've only got blue light coming in to our eye. What did that blue shirt do? Well, somehow it got rid of the red and the green. What it does is it absorbs. So just like a filter absorbs the other colors, a colored object, filters are colored objects if you think about it, colored objects absorb the other colors. So a blue shirt is absorbing red and green. And if you go back to the colored filters, blue is a minus red minus green object. So a blue filter is minus red minus green. Blue shirt, minus red minus green. And it absorbs the others. So for you to see this green rag, what colors is this green rag absorbing? So think about that. Okay, we start with red, green, blue. If we want green coming out, it must have absorbed the red and the blue. Yep. All right, so that's kind of the basics. What if we have a cyan shirt? So it's a cyan shirt. These colored markers are kind of making my life miserable. I really want to use the proper colors. So, source of light. We've got our eye here, looking at the shirt. What colors does the cyan shirt absorb? Well, we've got red, green, blue coming in. And for us to see cyan, what colors are getting into our eye? Well, cyan is made up of green and blue. So to see cyan, we have green and blue coming into our eye. So the cyan shirt absorbed the red. Same as with the filter. A cyan filter is a minus red filter. A cyan object is a minus red object. It absorbs. What color of shirt would we want to have all the colors absorbed? What color of shirt absorbs all colors? Make a prediction. Pause if you need to. What would absorb all colors? So we've got the sun or light source. We've got RGB coming in. What, if it absorbs all the colors, what goes into our eye? Nothing. There's nothing coming into our eye. So what do we see? We see it as black. Yep. So the shirt I'm wearing right now is absorbing the red, the green, and the blue from that light. And so your eye sees it as black because there's no color leaving my shirt. It absorbed everything. This is why in summer, if you are wearing a black shirt, you're going to heat up a lot because black is absorbing all three colors and it's absorbing all the light that comes in. So a black shirt in the light is absorbing a lot. Don't wear a black shirt in summer if you don't want to overheat. Conversely, what if we want no light to be absorbed? So what color would we have if we have our light source, we have RGB coming in, and then we want nothing to get absorbed, which means we have RGB coming out. What light is that? R plus G plus B? White. So no absorption. No colors get absorbed. Absorption, I think that's how you spell it. So in summer, a white shirt will keep you cool because it's not absorbing any of the sunlight. And so it's not absorbing that radiation, not going to heat you up. So this is the basics of colored objects. Colored objects pretty much behave like color filters. They're just subtracting other colors. They're absorbing the other colors. Now I'm going to add colored objects with colored filters, and let's see what we get. Okay, let's start with the first one, I guess. What color do I want to make it? Okay, I'm just going to erase it all. Let's say we have a magenta shirt, and there's my eye. And I'm going to put, I don't know, a red filter, a red piece of plastic in front of my eye. What color am I going to see through the filter? What color will this shirt look like through a red filter? See if you can figure it out. Use the same process. What gets absorbed from the shirt? What gets absorbed by the filter? What's left, if anything? Give it a pause. Okay. Red and green and blue are coming in. Magenta means that red and blue must get through. So green is absorbed by the shirt. And then a red filter, what does a red filter do? It only lets the red through, so it's a minus blue. This is a minus green. So the shirt absorbs the green, the filter absorbs the blue, the only thing that's left is red. So a magenta shirt looked at through a red filter, if you had a red piece of plastic over your eyes, would look red. That's how the process works. Again, it is subtraction. If I start with red, green, blue, and I have my magenta, well, I know magenta is a minus green, and I have my red, which is, it's technically both. Red filter is a minus blue, minus green. What's left? My red still gets through, green is gone, blue is gone. We see red. All right, next one, let's try. Okay, what shall we do? Well, okay. How about a green shirt? So we have a green shirt, and we're going to look through a magenta filter. So hold up a magenta filter to our eye and look at a green shirt through that magenta filter. What are we going to see? Okay, same process. Give it a try. Okay. Did you figure it out? Again, there's two ways you can think about it as each individual object, what is it pulling away, or you can do the straight up subtraction. They'll both get you the same answer. If we have red, green, and blue coming into the shirt, green, it's a green object, so our eye is going to see green because we have minus blue, minus red. And now the magenta filter lets magenta through, it lets red and blue through, it subtracts green. Nothing's left. So if you have a green object with a magenta filter, it should look black because we're just subtracting everything away. And to do it this way again, the green shirt, green is a minus red, minus blue, magenta is a minus green, gone, gone, gone. Looks black. And let's see, I got two more here. How about, oh, I'm switching it up. Ooh. Let's put the filter on the light source. So flashlight. And I'm going to do a cyan filter. So I'm going to put a cyan filter over the light source, and we're going to do a blue shirt. What are we going to see in this case? What color will that shirt look if it's a blue shirt under cyan light? All right, so we start with white. Cyan gets through, which means blue gets through, and green, because cyan is made up of green and blue. And then it comes and hits the shirt. Well, what does blue do? It subtracts red and green. So the green is gone. We have blue left. RGB, the cyan filter is a minus red. Blue is a minus red minus green. Gone, gone, blue. It's going to look blue. Then let's do one a different way. So if you can think through this, you should be in pretty good shape. I'm going to have a color filter again over my flashlight, and I'm going to say it's a cyan filter, and then we have our shirt and I want to know if we see the shirt as black, what color was it originally? So we see the shirt as black. What color must it have been originally? Not black to start with. So out of these 6 colors, which one would we put here in order to have it look black? Give it a try. And I'm going to do it this way to start with. Cyan is, it allows blue and green through. Cyan is a minus red. And then we need to know what's going on there so that all 3 get subtracted. So we need something that gets rid of the green and the blue. All right, so this shirt must subtract blue and green. What color shirt would subtract blue and green? Well, it must be a red shirt. So a red shirt under cyan light would look black because we got rid of the red here, we got rid of the blue there, we got rid of the green there, and we're left with nothing. Everything got absorbed. So there's color subtraction, both filters and objects. And so with this, you should be able to predict for any combination what color an object would look like, a colored object would look like under colored lights. So what would a blue object look like under cyan light, under red light, under yellow light? You should be able to do everything. And if you want to practice, what I sometimes have people do is a 6x6 grid where I do red, green, blue, yellow, cyan, magenta. So here's the filter that we put here, and then here are the colors of the object: red, green, blue, yellow, cyan, magenta. And so if this is making sense, you should be able to fill in all 36 squares. So a red object under red light is going to look red. So I don't know, let's do this one. A yellow object under yellow light, that's boring. How about this one? A yellow object under cyan light. Okay, so I start with red, green, blue. The yellow object in a cyan light. So a cyan light takes away red. A yellow object takes away blue. What's left is green. So a yellow object with cyan light would look green. And so you can just do this, and if you do that process, do all 36 squares, you should be in really good shape for figuring out color subtraction. All right, thanks for watching.